All right. So this one, it get kind of a doozy of an example, but it gets a point across. So for our example today, we're going to be evaluating the function of y equals, let's say 6. I haven't tried 6 yet. Y equals 6 of cosine x times sine x. What we're looking for today is we're looking for the first derivative and we're looking for the second derivative of this function. All right. So first things first, you will need to use the product rule. And the product rule states f prime times g plus g of prime times f will give us the derivative. So that's how you differentiate a product of a function. All right, so with that, we'll have f equals 6, f prime equals 0 because the constant, the derivative of any constant will equal 0. And then g will equal cosine x times sine x. Now g of prime, we have to differentiate this. Notice that this is also a product. So we will have to differentiate this using that. So in a way, it's kind of like differentiating within a differential. So the derivative of cosine x is negative sine x. That will be multiplied by sine x. And the reason why this is within this, we can look at cosine x is equal to g, and we can look at sine x is equal to, let's say, theta. We're just using it as a variable. So in this case, it will be g prime times theta plus theta prime times g. All right, so we got negative sine x times sine x plus the derivative of sine x is going to be cosine x times cosine x. That leaves us with negative sine squared x plus cosine squared x. And then all that will be multiplied by 6. Now, the reason why that is and why we don't have another one, because we initially said that we were going to be using the product rule, is because if we take the derivative of 6, we have 0. 0 times cosine of x times sine of x. We'll move this right here. That will equal 0. So it's best to not even write that out. But just so I cover all my bases, I wrote that out there so you can see. All right, so now we can go ahead and further expand this. So this, by the way, this will give us our first derivative. Now, we'll say that f prime is equal to 0, f is equal to 6, g is equal to negative sine squared x, and we'll say instead of theta, we'll use phi. Phi is equal to cosine squared x. All right. So kind of a convoluted way we're going about this, but without the power rule, this is what we have left. All right, so let's go ahead and differentiate g prime. So the derivative of sine is going to be cosine. So we have, let's go ahead and write this out. Or actually, hold on, let's make our lives a little bit easier. Let's go ahead and distribute that 6. So we have negative 6 squared x plus 6 cosine squared x. Okay, let's differentiate sine squared. All right, so sine x times sine x. The derivative of sine is going to be cosine x times sine x. Plus, again, it's just going to repeat, because whether this is f and this one's g, it will always lead to these two results. So that leads to 6 times 2 of cosine x times sine x. All right, now we're going to be doing, whoop, now we're going to be doing the same thing on this side. So got 6 on the outside, cosine squared x. All right, and the derivative of cosine is going to be negative sine. So negative sine x times cosine x minus negative sine x times cosine x. The reason why it's negative is because if we put the positive there, we'll just put the negative in parentheses, and either way it would distribute. So we might as well just write it out like that. So that's going to be 6 negative 2 sine x by cosine x. All right. So now notice that with these two, they look very similar. And there's a good reason for that. So you see that the order is cosine x and then sine x here. And this one is sine x and then cosine x. Truthfully, the order does not matter because you're multiplying against each other. So we can rewrite either one of them to fit the other. And we're going to do that now after we distribute the 6 with the 2. So we have 12 cosine x times sine x and negative 12. Ooh. Almost slipped up there. I'm actually supposed to carry the negative 6 from the previous one. Kind of forgot about that. So it's going to be negative 12 times cosine x times sine x minus 12 cosine x times sine x. And we can go ahead and add those together, or I guess subtract them, however you want to look at it. Negative 24 times cosine x times sine x equals our second derivative. All right, so it's kind of convoluted without using the chain rule, but that's essentially the bare bones method of doing it. Yeah,